because of the ad hoc nature of the code we're going to be writing, I'm not going to split this into 3 lessons. Plus, some of this is going to be used as a template anyway, so it will reduce the code that we write even more. So before I get to the proprietary code to the script, I'm going to write out just the general outlines of a movement script. Going to start off by assigning a motion speed as a public parameter, so then I will be able to modify it in the inspector. Rotation speed. Then I do not need to put anything in the start function. This is going to be a relatively simple script. So we'll need to do something every single frame. So I'm going to use the update function. Now I'm going to assign another float variable. I'm going to call it up and down control. And I'm going to utilize the getAxis command. GetAxis in order to determine how much the user is pressing either the WS keys or the up and down keys. We've covered this before. If you do want to assign these values yourself, they will be in the project settings. And I need to specify which one will be being used. In my case, it's vertical. Left, right will be used for rotation. So again, input class, the getAxis function, which will return a float. And now we're going to get to the code of this specific script. Now, the function that we're going to be using is a simple translate. This means that everything is going to be simply moved from one point to the other. Rigid bodies will not play any role. Now, you might not think of a use for this for our specific character, but in your game you might have something, might not have ghosts coming out of the walls, but you could have some other objects that would come out of a place which would be inaccessible as a passage to the character, but you still want them to appear there. So in this case, this script would be exactly that you would need, considering some object coming out that does not need to interact with anything, does not need a rigid body. So I'm going to write down vector3.forward, which is another way of writing new vector3, and then writing 0 for x, 0 for y, and 1 for z. So just a shorthand, vector3.forward. And then I'm multiplying this value, so it means the x is being multiplied by this value, y is being multiplied by this value, and z is being multiplied by this value. Only in our case it's 0, 0, 1, so only the z gets multiplied. And I'm going to multiply it by the up-down control. So this is going to be a value from -1 to 1. I'm going to multiply it by our motion speed. And then I'm going to multiply it by time.delta time, and this will make our movement frame rate independent. And that's all we need for the movement for forward and back. And let's write out a rotation command. Once again, transform.rotate. We specify which axis do we want to rotate around. It's going to be the y-axis, so vector3.y.up times rotation speed times left-right control, and once again times that delta time. Okay. Let's bring this back to Unity. Okay, we're not getting any errors in our console, so let's go in our hero and apply our first script. We're going to need to give it some sort of movement factor. 10 by 50, that's fine. And Okay, let's see if he, I'm going to just, let's select it. Okay, let's see if he moves around. Okay, rotation seems to be working, up and down. And as you can see, there's absolutely no interaction with physics in any way. So this would probably not be very useful specifically for this character, but like I described, maybe if you want something to appear out of the wall or not out of the wall, it's some sort of passage that is not open to the character, this would be the script that you would use. In this next script, we're going to learn how to move the character around directly with rigid bodies. I'm going to cannibalize some of this script from the first movement manager, and now I'm going to, because I'm going to need to access these two floats up here, these two variables outside of the update function, I'm going to go ahead and bring them up outside of the function. So we need to determine how much the button is being pressed. -1 to 1. Now we're not going to be using the translate or the rotate functions because we're going to be dealing with rigid bodies. And because we're dealing with rigid bodies, we need to calculate this outside of the update function. Because we want the physics to be consistent for every physics step, we need to assign them on a consistent draw call, which update is not, because update takes a different amount of time to calculate per frame. Fixed update, on the other hand, provides a regular interval and should be used with rigid bodies. We're going to address the rigid body component, and we're going to add a function which is going to be called add relative force. And what this does is that it adds a force that is on a local axis to a vector 3 that we would specify. So I want to add force along the vector 3, or excuse me, along the z coordinate, although of course I could add force on, I don't have to type in one single axis. I can use all three axes that I want, but in this case I only want the character to move forward, so I'm going to use the vector 3 forward shorthand. I'm going to once again multiply this by the get axis float up here to get the value from -1 to 1. Multiplied by motion speed. And that's it for the force. I'm not going to be multiplying this by the delta time because fixed update provides us with a regular intervals from which we want to execute our commands. Secondly, I'm going to need to apply a rotation command, and now we're going to add torque. And torque is application of force outside of the center of mass, or something that is attached onto something else. Perhaps you can think of it as a clock needle that is being pushed, and it's going to be rotating around the nail. And when it's pushed up, torque is being applied. So I'm going to apply force outside of the axis of rotation of a certain object that we want to affect. In this case, this is going to affect the hero. Okay, so I want to apply this around the y-axis multiplied by rotation speed factor. And actually, let's keep with our convention and multiply by the get axis command first. Left, right, control times rotation speed, and we are not, once again, going to be using the delta time function. Save, and let's bring this back to Unity. So as you may remember, a rigid body will need colliders in order to interact with its physical world. A simple mesh without a collider will not be affected by the physics. So I have created just two simple colliders. Both of them are cubes, and one of them is at an angle with box colliders for each one. I'm going to go into our hero and remove in the manager A, attach movement manager B. Let's start off by giving it some sort of motion speed, rotation speed. And because we're going to be using rigid bodies, we'll also need a rigid body component and a collider component. So go ahead and go to the component file menu, physics. We're going to use a capsule collider. Let's move it up a bit in the center, vector 3. Move it a little bit higher. Adjust the height here. And radius is going to be fine. I'm going to leave it as is. Now go ahead and apply a rigid body through the same component, or excuse me, through the same file menu. Rigid body. Okay, just from the get-go, let's see how it looks. Okay, so we have our hero, seems to be rotating. Now this is probably rotating a little bit too much, but it's still better than just rotating it a regular way. And we see because we're using rigid bodies, the character doesn't always maintain the position that we would like. And I think he's pretty much gone for now. Okay, so there he's fallen through the floor. We could do some patches to this rolling around effect. For example, we can disable all rotations except based on the y-axis around what torque is pushing the hero around. So now the character won't fall down as easily, and I can move them around and he will interact with physics objects. So this is still better than the script we had before, although now it's a little bit unstable. And perhaps it's a little too unstable to be used in a character control script, but if you are controlling rigid bodies that are being affected by the hero itself or just inside your scene, and you need to use some sort of physics interactions, then you probably would want to use a script that's similar to the one that we wrote. So lastly, we're going to cover a certain component, a certain class called a character controller, which will still implement a rigid body and will give us more stability when moving the character around. So let's begin by opening up Movement Manager C. Okay, once again, I'm going to commit some acts of cannibalization. Movement Manager A, I'm going to take some of these commands and delete the ones that we have here. And just paste them in. We'll still need both of these parameters to specify speed. And this time we're going to be working in an update function. Even though this is going to be internally using the rigid body, the character controller does not require the adding of that component. So we're going to be keeping both of these floats up here. That's fine. This time we're going to add a start function and a couple more private variables. First one is going to be a character controller variable, which is going to reference the character controller component, the class. And second is going to be a vector 3 called a move direction. And this is going to specify exactly where the character will be moving. To specify that, we take a familiar approach. Move direction equals vector 3 forward. So z-axis times up, down control times motion speed. Because we're going to be working inside the update function and not directly with the rigid body, we're going to add a delta time component, or excuse me, delta time function in order to make this frame rate independent. Now we're going to do another command in order to change the translate based from the global axes to local axes. And for this we're going to be using something called a transform direction function. So we're going to be referencing the object's transform direction, and in the parameter we're going to be specifying this vector 3. Now we're going to access a function called move within the character controller, and we're going to tell it to move along this vector 3. So character controller dot move and move direction. Okay, we'll start off with this script, and I'm simply going to add a simple rotate function. Rotate 0 left-right control to get the float from -1 to 1 times rotation speed, and 0 for the z-axis. Lastly, we want to add a start function and assign this character controller to the component. So type in character controller equals get component character controller. We're going to make this script a little bit more sophisticated, but I'd like to show you how it currently is within the game. It looks like we're getting some sort of error. Unity tells us it's on line 22, unexpected symbol, close parentheses, expecting a semicolon. Looks like I made a typo. Let's go in here, okay, line 22, and there is our error. Yes, so you can see that I never open the parentheses, but I'm closing it. Force of habit, I suppose. I'm saving it. I'm going to go back to Unity, and we are getting a clear console. Okay, so let's assign the movement manager C onto our character. Once again, give it some sort of motion speed, 10, 20, and add a character controller component. To do so, just click Add Component, type in Character Controller, press Enter, and we see that it gives us some parameters up here. Let's only concern ourselves with just one. We see that this capsule is placed a little too low for the floor of the character. Let's move it up a bit in this center parameter of the vector 3. Just bump it a little bit higher, and I'm just going to press play. Okay, so there is our hero. Let's see, the controls are functioning pretty well. We see that when I apply the rotation, when I apply the torque, the hero will be rotating for a little bit more. Movement. The character is moving around, and we see he's not stopping at a halt. Now this is what's sometimes called to as Doom-style controls from the game Doom, where the character would move around at 100 miles an hour and then stop and halt at one single point and turn around on a dime. So it's a little bit too unrealistic. And rigid bodies are a little bit more finicky to operate with, so this character controller implements a rigid body, interacts with colliders, and gives us this physical verisimilitude. So it's pretty handy. Now, as we can see that there is currently no animations, and there's also no gravity applied. So let's go back into our script and implement these controls.